Hello. I'm recording the fourth video for the day. It is 3:30 a.m. Strangely productive tonight. How's everyone doing? Anyway, I shall start. And let's make this a bit fun, because it's the last circuit video. You have come very far. This circuit, I kind of like put together all the weird circuits together, and I think I'm just going to do a rating lah. I will rate the circuits later for you, okay? So I will rate it. See lah, I'll come up with some random rating. So it's a nice chill video where we listen to some Studio Ghibli music while I talk to you about some other circuit connections, and we can rate the circuits. You can choose your favorite one. Anyway, I classify bridge circuits as any form of circuit where you have a connection of resistors, okay? And this kind of bridge circuit, right, the way it works is that we will still adjust or have a variable resistor. So it can be one variable resistor, it can be two, it can be all. Freestyle, guys, freestyle time. It's like you spend so much building your EXP of circuits, now it's time to go all out. Alright, anyway, here you can see that there's a network of resistors, 4 of them, R1, R2, R3 and R4. And what will happen is that we will adjust until the galvanometer reading is 0. Okay, so let's say R3 is the variable resistor. Okay, and like this, in this case, if let's say you want to follow the same circuit, so they are kind of like the same connection. And what I mean by that is, if let's say you struggle with understanding what I mean by, oh, the circuit is the same connection, well, my friend, you can just follow the current. Current will come out from the battery, okay, current come out from the battery, reach point A as a junction. So this point is point A. Make sense? I think maybe I need to make this diagram bigger. Ding 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 ding. Oh, cannot, because I deleted all the values. Okay, never mind. Forget that. Where were we? Alright. So once you reach point A, right, the current be like, oh guys, we got two choice. We either go to R1, ding 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 ding, or we could go, and then we have to go to R3. So maybe this can be your R1. Well, frankly, it doesn't matter whether it's the top or the bottom one, okay? So this will be R1, and then ding 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 ding, this is R3, and then you go back. Life is good, guys. Life is good. See? The second option would be to go to R2, reach point C. So R2 would be here. And then go through R4, like that. And then go back out. Ta-da! Okay. And this will be your meter line in the middle. So you might be thinking, right, actually your miss, wouldn't any current flow through the galvanometer? Well, my good friends, you know what we'll do? We will adjust the meter until, we will adjust the resistor until you get a 0 reading. Okay? We will adjust the resistor until you get a 0 reading. Now, spoiler alert, there's a circuit that looks something like this somewhere in your near future. I don't want to tell you when, but somewhere, somehow, don't know when. Okay? So, then you will observe. I won't even tell you when you are having the experiment. See whether you can notice or not. Bonus point if you can. Let me know. Alright, so from here, you can see that these two circuits are the same thing. It's just that they are drawn differently. So if you trace the direction of the current, you should be able to tell whether the circuit are the same or different. It's the same circuit. Alright, guys? So the working principle here is, number one, we are going to adjust the variable resistor, R3. So R3 here, in this case, it looks like a thermistor. You can see the shape is a thermistor, or in this case, it's a variable resistor. Okay, fine. Maybe I'll change it to a thermistor. The thermistor looks like a spoon, you know, like that. Yeah. Okay, so let's start. Number one. Okay, so the thermistor can be a variable resistor, can be anything lah, huh? So a thermistor R3 is heated gradually until the galvanometer reading is 0. So if the galvanometer reading is 0, what this tells you is that the potential at B will be equal to the potential at C. So that it will be a case of you shall not pass. Okay? Cannot pass. Alright? So it's another case of you shall not pass. And if you shall not pass, it means that the potential difference across AB, I'm going to label this, okay? So it means that the potential difference across AB here to here will be the same as the potential difference across AC here to here. Can? So this is VAB, this is VAC. They must be the same, okay? So VAB will be equal to VAC. Alright? And at the same time, the potential difference across BD, I'm just going to use red for this one, VBD, here to here, will be equivalent to VCD. Now, to just drive home this point to you after I write this down, I'm going to draw this beautiful thing that you learn in maths called the number line. 你知道 what is number line or not? Okay, never mind. So I'm going to draw a number line here just to represent the circuit for you lah. And because you like to think in boxes, I would like to think that this will be a bit more straightforward if it's drawn this way. Okay, so you have two resistors here. So instead of drawing the resistor, I'm just going to draw the points. So this will be point B, this will be point C. These two are actually the same point, you know. This is point A. It's the same wire, guys. It's the same thing. So this also will both be point D. So here's my question. If you want imagine a number line. Okay, imagine this is connected to 10 volts. Okay, just to make your life easier, this one is connected to 10 volts. Which means whatever it is in this number line, this one must be 10. It's a weird and decreasing number line, but live with it, okay? And this one should be 0. Okay? If you want B and C to be the same, I don't know what B and C is, whatever B and C is, but you want B and C to be the same. So that means if here to here is 7, then here to here will be 3. But if you want B and C to be the same, which in this case 10 minus 7 means this point here is 3 volt already. Okay, then here to here must also be 7. Make sense? If not, they cannot be the same. Alright, so yeah, it's like building two slides. If you want the height of the slide to be the same in the middle, and given that the height of the slide before and after is the same, then at any point in time the slide will have the same height. Okay, but we shall continue with these two equations. Now I know you know V equal to IR because I nagged you so many times already. Okay, so let's assume that the current through the branch AB, okay, the current, this green current, I will call it I1. Tiny I1 there. Can you see? Is it too small, guys? Is it too small? Okay, much better. But I have no space to write. Such a dilemma. Okay, anyway, this will be I1. And this down here will be I2. Okay, so I'm just going to plug this in before I zoom out and derive equation. So here, you will say that I1, plus the potential difference across AB, I1 R1 will be equal to the potential difference across AC, I2 R2. Okay, life is good. Moving on. Dun, dun, dun. Okay, potential difference across BD would be, so it's the same current I1. Remember, because the current will not pass through the galvanometer. You will heat up the thermistor until the galvanometer reading reads 0. So this will be I1, BD would be R3, the thermistor, and CD would be I2 R4. Okay, how would you simplify this equation, ladies and gentlemen, boys and girls? Divide law. You see the I1, I2 is screaming to be divided so that they can cancel out. So if I divide them, I will get I1 R1 over I1 R3 will be equal to I2 R2 over I2 R4. Can cut all the things. The derivation can be asked. The equation does not need to be memorized. I honestly don't think you will take a long time to derive it if you understand the idea behind it. Okay? So the main idea here is, number one, a certain form of variable resistor will be heated or changed until your galvanometer reading is 0. Once your galvanometer reading is 0, what happens here is that, let me adjust. What happens here is your potential across AB will be the same as the potential across AC. Here the potential and here the potential is the same potential. Okay, and then BD will be the same as the potential across CD. So if you equate the potential and then you apply V equal to IR, your multi-purpose equation in this topic, and then you just simplify the equation. Alright, by dividing them. Okay, let's try some question and let's rate the circuits, guys. Let's rate the circuit. Oh boy, this one's so cute. Okay, so this one is a terminal box connected to a battery. They are not all potentiometer lah. Actually, by the way, this thing is called a Wheatstone bridge. Alright, it's a particular name lah, but the name they never mention in your syllabus. So okay lor. So this circuit, looks very easy. I rate this a 2 out of 5 in difficulty. Maybe a 1.5 out of 5. Okay, so you have a 4-terminal box connected to the battery with 2 ammeters. Current in the 2 meters are identical. So this is the important point, the current is the same. So this is generally what I mean by wildcard circuit. You kind of don't know what you're going to get. Which circuit within the box will give you the result when the ammeter reading is the same. So my suggestion is you draw the circuit inside and see how. Okay, so the first one looks very suspicious. And suspicious because this loop is disconnected. You see here it's not connected, right? So in this case, the first ammeter, let's say I call this ammeter 1 and ammeter 2 just for the sake of discussion. Ammeter 1 will have a reading, ammeter 2 no reading. Okay, moving on. The second one has a circuit. It looks like this. Ayo. In this case, do you know how the current will flow? The current is going to flow like this. Let's leave the positive terminal, pass through ammeter 1. I either go down this resistor, which I can do, but got work. I don't wanna. Or I could go straight, go through the second ammeter, and then just bypass the resistor, because ain't nobody got time when there's an alternative where I don't need to go through a resistance. Ideal ammeter have 0 resistance. This is what I mean. Grammar. Okay, so in this case, right, I can say ammeter 1 is equal to ammeter 2, but I also kind of want to check the other connections too, which I will do so now. Ding. Okay, so let's consider option C. So option C, you have a resistor here. Okay, and it seems fine until you notice that this number 1 becomes a branch. BRANCH. So this one will reach this point and then it will split into 2. One will go here, one will go here. Okay, so let's say the current here is I1, will split into 2. One goes here, one goes here. So ammeter 2 is only measuring a part of the current that enter the branch 1, Kirchoff law. So in this case, right, the reading for the first ammeter is less than the second ammeter. No, wait, first ammeter is greater than the second ammeter. Okay, because the first ammeter gets all the current, and then the current is then split into 2 branches. The second ammeter only get the current from one of those branches. Nah. So we only get this current. The current that passed through the resistor didn't measure. Okay? This down here, the resistor down here. In this option, no current will not choose the resistor down here because there's another option where it's free. In this case, there's no free option. Both options also got resistor. So both branches also will have current. Okay? Alright, moving on. 来电了 okay lor. So if now you connect this way. Connect this way. Your current will flow like this. Is it correct? Yeah. It's just the same loop. Right? Am I wrong? Oh no. The current will flow like this. It's the same loop. This one is also equal to 2. So which is better? Is B better or is D better? Well, actually, I pull a fast one on you lah. If you consider the connection for B, right, where the resistor is like this, and this one is like this, and this one is like this. Remember I told you the current will always choose the the part of 0 resistance if that option is available. So actually, yeah, the current will flow here. Were you tricked? Did I did a good job? Current does not flow here at all. It will just go through the ammeter and then just come down. Aiyo. So in this case, 1 is not equal to 2. 1 got reading, 2 no reading. Okay, so the answer will be D. At this point, if you have been watching my videos, I will drop a hint to you lah. If I set this question, I'm gonna keep everything, and then I will just say it is found that the current in ammeter 1 is greater than ammeter 2. Which of the option give you this outcome? That's what I do lah. That's what I always do. Okay? Okay, moving on. So this one is a 2 out of 5. Okay lah, but can do lah. 5 out of 5 will recommend you do. Alright, so this is a circuit. Oh, good lord, look at all the resistors. Okay, what will be the reading of the voltmeter? Someone they connect the voltmeter in such a weird way. Yeah, guys, don't panic. This is a potential divider question. It's a 3 out of 5 question. Not hard. Very easy. Okay, so let's check branch by branch. Alright, so let's take this branch A to branch B. Now branch, you know, the more I talk about branch, the more I think about food. Branch. Okay, now sorry, side tangent. Alright, anyway, you have 2 identical resistors in series. So this is 1.5 volt. They share lor, equal share, 1.5 volt. Okay, this means the potential here is 3 volt. Drop 1.5 volt, become 1.5 volt. Drop another 1.5 volt, become 0 volt. This is what it means by having a potential difference of the battery set up to 3 volt. That means between AB is always a difference of 3. So if you take 3 and 0, that means 3, drop 1.5, become 1.5. Drop another 1.5, become 0. Okay? Oh boy, let's look at this branch. Actually, this whole branch, I don't care what resistor they draw. I just need to find the effective resistance. And then since this one is all 1, 1, 1, 1, 1, 1, 1, 1. So I'm just going to simplify the branch. Let's say this is the branch CD. Okay, so I'm going to renovate CD or do a KonMari method. Does this spark joy? And simplify the circuit. Simplify my life. Okay, so let's look at this 1, 1, 1. 1 over 1 plus 1 over 1 inverted is half. Okay lah, come lah, I do slowly lah. So I don't know I don't know CD. Let's call this M. I call this M lah. I call this N lah. Okay. So from C to N, you have the resistance from C to N would be 1 plus 1, so 1 over 1 plus 1 over 1 inverted plus the other one in series. So this one is 0.5, okay, so you get 1.5 ohm. Okay, what about the resistance between N and D? 111 in series. 111 in series. So if this 111 in series, 3 lor. So 1 over 3 plus 1 over 1 whole thing inverted. This would be 3 over 3. So let's double check. So if I didn't tell you yet, the reason why I write this way is because I am that blur case student who forgot to invert the answer. And then the whole thing wrong. And then I get very annoyed. Like, why like this? 为什么? 3 over 4. 3 over 4 or 0.75 ohm. Okay? So let's think about ratio. Or let's KonMari the branch CD because it's too complicated. This one is 1.5 ohm. This is C. Now if I'm teaching in the whiteboard, I would have rubbed off the whole thing lah, but then it's not possible now because, oh well. Anyway, ding 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 ding. This one is D. So this is 0.75 ohm. In other words, right, the potential difference will be shared with a ratio of 2 is to 1, correct? Meaning here to here will be 2 volt and here to here will be 1 volt after I KonMari all the resistor lah. So if this is 3 volt and this whole thing from C to N is 1 volt, 3 volt minus 1 volt will become 2 volt. So this one is 2 volt lor. And 2 volt minus 3 volt minus 1, what am I talking about? Sorry, this is 2 volt. It's late, guys, it's late. I think I know why wrong. The arrow is not perfect, that's why. We need the perfect arrow, guys. We need a perfect arrow. Why am I ASMRing the circuit? Do you want an ASMR video? Okay, never mind. JK. Alright, so this one, what was it again? 2 volts. That's it. So 3 minus 2 makes this 1 volt. Okay, and 1 minus 1, because here to here is 1 volt. So this one will go back to 0. I tend to do this just to double check lah, because you know my math's not so good. So to find the reading on the voltmeter, one side of the voltmeter is 1.5 volt, the other side of the voltmeter is 1 volt. So it will be 1.5 minus 1, 0.5. 5 out of 5. I recommend this question. Very good, very nice. Okay, so let's look at this one. A 20 volt power supply is connected to a circuit consisting of 5 resistors. There's a potential drop of 7 volt and 4 volt across L and N. What are the potential drops across M, P, and Q? Okay. There's a 20 volt rise across the resistor. So, here to here is 20. This one is like maths puzzle. I refuse to give you an equation, guys. You are smart, you can do one, no need equation. Okay, here to here is 20. 20 dropped by 7 means this point is 13 volt. Okay, can. Now 13 dropped by 4 means this point here is 9 volt. So far so good. Okay, so you know here is 20, this line is 20, you know this line is 0. If 20 minus 7 is 13, 13 minus 13 will be 0. So here to here would be a 13 volt drop, negative 13. So wrong and wrong. Okay, so now this one is 9 volt, and you know this line is 20 volt. So 20 minus what give you 9? 11, no? Because we all pass primary school. Sometimes I don't lah, but okay, you got answer already, but let's double check. You know everything on this line is 0 volt. So 9 minus what will give you 0? Minus 9 volt lor. Yay, the answer is C. So easy, very nice. I like this question. Looks hard but easy. Okay lah, I give it a 2 out of 5 in difficulty, but 5 out of 5 in recommend students try. Maybe like every question is 5 out of 5 I miss. Hiyo. Okay, so this one, this one a bit trickier lah. So here it is a box with 4 terminals as usual. When a battery of E and negligible internal resistance is connected across PS. Okay. I quite like this kind of question because it's a bit like the real world lah. When you go and do proper, it's like you have a circuit board where you can connect stuff. So this is actually closer to the real world, not the crocodile clam nonsense. I mean, sorry, the crocodile clam. We will connect EMF E with no internal resistance. This was E. A high resistance voltmeter is connected across QR. Okay, so we're going to put a voltmeter here. And this voltmeter has a reading of E over 2. Which diagram shows the correct arrangement of the resistor inside the box? And you might be thinking, Misa, if we connect a voltmeter across QR, then we can connect another resistor across QR. Can. 2 connection can share 1 input. Okay, so if it makes you feel happier, I draw the voltmeter out a bit lor. You can connect voltmeter this way one ma. If you got KHB, all the students that watch these videos are from IG. If you did your life skills before, you will notice that all the electrical component has a 2-prong thing. Okay, so you can share the same position. Anyway, this will be the voltmeter, and the voltmeter reading is E over 2. Okay, so let's try one by one. How the first one look like this? This one like this. This one like this. This one is here. So you can see that. Just check the current flow lah. Okay, so I'm going to. The current will flow this way, this way. It will never enter the voltmeter because ideal voltmeter has infinite resistance. Okay, so it will go this way and then return back to 0. So if you look at this particular connection, right, these 2 resistors are in series, and if they are identical, which they are, there, the voltmeter is only measuring the potential difference across one of the 2. So indeed, this one is E over 2. This is correct. Okay, because it's 1 out of the 2 resistor. But if you're paranoid and have trust issues like me, I check everything one. And then I think about how to modify the question. You think together with me lah. Okay? While I draw the circuit because... wow, this one like this Okay, sure. Why not? Why not? PS is also now called... So I'll connect the battery this way then, easy to see. It's the same thing, okay? So now, when we connect this alright, then you gotta ask yourself, where will the current flow? Come out from battery, all the current will go this way. Miss, nobody go to this resistor across PQ. The answer is no. Because if any ngong current go inside this resistor, this ngong current will also pass to the voltmeter. And the voltmeter has infinite resistance. No one can survive infinity. Maybe Buzz Lightyear, but not current. So current won't even entertain the idea of going through this bigger branch here. Won't even entertain going through this branch here because of the voltmeter. So only current will only go through this one. So in this case, the voltmeter reading is the terminal voltage because the voltmeter is connected across the terminal. Check the terminal of the voltmeter. Terminal of voltmeter is here, which is the same as the terminal of voltmeter is here, and any resistor connected in series with voltmeter is irrelevant. Okay. Alright, so then this voltmeter reading would be equal to E. Terminal voltage. Okay, let's continue. Okay, what happens when we connect this one here? One like this. This is C. Okay, so if you connect this way, the voltmeter is connected across an empty wire. One thing, okay? And the second thing is, the current is already flowing. So it is not measuring the terminal voltage directly because it's not, how should I put it? If I connect this way, no current will flow. Then this one will be equal to E because it is connected directly to the terminal. But now there's a connection here, meaning current will flow this way, like that. Okay, but because there's nothing on this wire, meaning there's no energy converted from electrical to non-electrical, so this one will be 0. Voltmeter is 0. Okay, last one. This one means that the resistor, and then like this, and like this, and like this. So weird one. I confirm cannot lor. I don't know what this is measuring because the current will flow this way and that's it. And the voltmeter is not even connected. So this voltmeter reading is 0. Okay lah, you go and think lah how I can modify the question. I recommend. So this one would be maybe also a 3 out of 5. Kinda, sorta. Alright, let's go on. Maybe a 4 out of 5. I quite like that question. Okay, so there's a current P to R in a network of resistor, sure. Potential difference between P and Q is 3 volt, and then this is 6, blah blah, label already. Which one in the table is correct? Okay lor. So if this is 3, this is 6, mean the whole thing is 9. Meaning this will be 5 and this will be 4. So between SR, it has to be 4. Wrong. Okay, so this is 9 volt. 9 minus 3 is 6. So this point here is 6 volt. If this whole line is 9 volt, then 9 minus 5 is 4 volt. So if you want the potential difference between Q and S, it will be 6 minus 4, which is 2. So the answer is A. Very easy. 1 out of 5 in difficulty. I'm not setting your objective, so you don't have to worry. Trials lah. Oh, this one. Okay, I tell you what. Good lord, what is this? Okay. I have selected many complicated ones I have seen. Okay, never mind. I shall start from the bottom then, since I scroll here already. So, in the circuit below, the ammeter reading is 0. Sure. So, no current is flowing through here. Wonderful. What is the resistance of the resistor R? So when this came out in my students, right, they all like panic sebab because they don't know where's the direction of the current, and they are like, Miss, this branch how let's say the current flow like this go here meh? Then I'm like, if the current go here, how can the current come back? You understand where I'm coming from? You might be thinking that the current can go like this, like this, like this, like this, like this. How to go back? You got play maze before or not? You cannot go up this 100 ohm, because once you reach this 100 ohm, you know, like Pac-Man, the current is flowing in to the left. You have nowhere else to go. You might say, can go here. Cannot. Ammeter is 0. So what I'm trying to say is, if the ammeter reading is 0, it also means here got no current. So it's actually 2 separate circuits. Okay. Anyway, for here to have no current to flow, the potential difference have to be the same. Remember, the idea here is that the potential difference have to be the same. So it means that, let's say this is point A and this is point B, VA must be equal to VB. Okay? So let's consider the ratio. I'm just going to do ratio without showing working. This point in time you can one. This ratio is 50 to 100, which is, the ratio here is 1 ratio 2. Why I write that? Never mind. The ratio here is 1 to 2. If the ratio here is 1 to 2, hang on. The ratio here is 1. The ratio here is 2. Ratio. Okay? So this means that the potential will also be 1 to 2. So a 1 to 2 ratio would be 4 to 8 volt. 4 volt plus 8 volt will give you 12 volt. Okay, can I? Okay, so this is the positive terminal. So this is the higher potential. So everything up here is 12 volt. 12 minus 4 will give you 8 volt. So VA is 8 volt. Okay, 8 minus 8, then you give back 0 volt. Then you return back to the negative terminal. Okay, so in this particular case, right, what is happening is there's no current flowing through AB, and the ratio of the potential difference will be evenly divided according to the ratio of the resistor. 50 to 100 is ratioed at 1 to 2. Okay, so then the potential difference will be 4 to 8. 1 to 2 is 4 to 8. Double ma. And 4 to 8 is 12. Okay, so this point here would be 8 volt. Next, VB. So if you want this situation to happen when your ammeter reading is 0, then this also will have to be 8 volt. Correct? Meaning to say, wow, the ratio is not 1 to 2, guys, because now we are dividing 24 volt. Make sense? Okay lah, we can use ratio lah if you're more comfortable. So up here is 24 volt. Okay, 24 minus what will give you 8? The answer is 12. 12 no, wait, 16. Okay, so 24 minus 16 will give you 8. And then 8 minus 8 will finally give you your 0. You can return back to the negative terminal. Okay, so if this is 8, the one is 16, you can do ratio. I mean, it's up to you how you want to do it. The ratio here is 2 is to 1. Okay lah, I don't want to use equation lah. The ratio here is 2 to 1. Right? So if 200 is 1, then 2 would be 400 lor. Then the answer is C. Okay? So not hard. Just the main idea where if there's no current flowing, then these two branches cannot have current flow. Meaning the potential at A must be equal to potential at B. Then you just use ratio. 1 to 2. So 4 volt, 8 volt, meaning here is 8 volt because 12 minus 4 is 8. Okay? Just like if this is 8, but up here is 24, then the ratio will flip to 2 is to 1. Because 24 minus 16 is 8, and 16 to 8 is 2 to 1. So if 1 is 200, then 2 is 400. Okay? Very easy. I like this. 5 out of 5. We'll set again. Alright, this one. May, June 18. So you can see the recent questions. Some of them are actually quite tricky. Okay? So in this circuit, XY is a length L of a uniform resistance wire. A potential difference is applied across XY. R1 and R2 are unknown resistors. J is a sliding contact that joins the junction R1, okay, fine, with a lamp, sure. So in place of a galvanometer, today we have a lamp. Okay, so potential difference across R1 is V1, across R2 is V2. So this is V1, this is V2. What's the ratio of V1 to V2? So you move the jockey until this one is off lah, so there is no light. And this one is X. Okay, sure. Okay, there's no current here. This is J. Let's call this, you call XY, I call AB or, and then the middle here I call M law. Okay, so if there's no current flowing, the potential difference across XJ will be equal to the potential difference across AM, which is V1 lah. Okay, and the potential difference across JY will be equal to V2. Oh hey, so easy. So V1 over V2 will be potential difference of XJ over potential difference of JY. But also at the same time, right, V is equal to IR. R is equal to rho L over A. So V will be equal to I rho L over A. My ladies and gentlemen, boys and girls, rho and A and I are constant because this thing is in series. And no, it cannot pass through J because the light is off. So then what do we have? We have V is proportional to L. Okay, so what we need to do is just substitute the length of XJ on top, which is X, divided by the length of, where is this? JY. JY would be L minus X. So the answer is D. Yay! Okay. Alright. Okay. Next. Good lord, what is this, miss? What is this? All in one lah. They just put everything together and 5 out of 5. I like this one. Okay, so you got a wire like a potentiometer, 100 cm connected with cell L. Another cell M is connected in series with resistor 5, 10, 15. Wonderful. Potential difference between PQ is balance. Balance means ammeter reading is 0. Okay, against 12.5 cm of the resistance. So the ammeter reads 0. Damn it. The potential difference across the other resistor is then balanced against the other lengths of the resistance wire. So what they're trying to tell you is the potential difference from here to here is equal to here to here, and the potential difference from here to here is equal to here to here. That way, no current will flow. So familiar. It's like Wheatstone Bridge. Correct lor, you are right. If you don't see it, then they try to help you. Anyway, which balance length of the resistant wire corresponds to the connection points given in the table? Aiyo, easy peasy. Use logic 5 ohm is 12.5 cm. Okay, so whatever the potential difference is, 5 ohm corresponds with 12.5 cm. Okay, so now if your connection point is Q and R, Q and R, Q and S, and P and R. Okay, so QR is 10 ohm. If 5 ohm is 12.5, 10 ohm will be 25. Ta-da! Okay. Q and S is 25. Q and S 25. If 5 ohm is 12.5, 25 ohm will be 12.5 times 5, which is 62.5. Ta-da! P and R. P and R is 15 ohm. 5 ohm is 12.5. 15 ohm will be 12.5 times 3. That would give you 37.5. Ta-da! So, yay! This is the Instagram thing where you... Oh, bingo. Circuit bingo. Nah, that's speed. Okay, not difficult. Remember what did I say? Ratio is my best friend if you know how to solve it. Multi-purpose ma. Alright, and finally we are at the last question. Meetings, I think so too. Okay, yep. So in this last question, wow, 46 minutes now. You guys can speed up the video, but then at this point in time I tell you why did I tell you so late? Anyway, so here you have a resistor S. Okay, these two is identical. IDK what resistor this is. Kirchoff laws can be used with the data to deduce the resistance of each of the two identical resistors labeled R. You're trying to be helpful. I don't know whether it's helpful, but okay lor. So 4 ampere is here. The 3 ampere will go up, the 1 ampere will go down, and then you got 3 ampere here, 0.5 going down, meaning 2.5 is left behind, and 1 ampere marry 0.5 ampere will be 1.5 ampere, So what is the resistance of the resistor R? You can use Kirchoff's second law. Choose the loop. I will choose a loop with the least unknown so that I don't have simultaneous equation. Why would I want a simultaneous equation? Life is hard, guys. Life is hard as it is. So I could use this loop. I'm just going to call this loop 1. Loop 1. So sum of EMF is sum of IR. This is a Kirchoff second law question. I just chose the question because it's nice. Alright, so where were we? Sum of EMF is 0. The current, okay, you need to first choose the direction in which you want to loop. Okay, so I'm going to loop clockwise because just simply I like to loop clockwise. So when you loop clockwise, you will notice that the 3 ampere, you will be thinking, okay, I loop clockwise. 3 multiplied by, oh no miss, you see here we ain't got this resistance miss. Oh no. So I mean you can continue this road, but then you will notice that without this resistance your equation will have 2 unknown. No, actually your equation will have 3 unknown. You don't have this resistance, you also don't have S. So you're like, dang it, how do I choose a loop? True story, you know. I'm just playing things out as it would look like in the real exam for you, so you don't get the idea where just because I can solve it very quickly that you should be able to solve, unless you practice a lot of kung fu like me. Okay, so actually the loop that we all should be using is this one, my friends. This one, because all the components I pass through. Okay, generally when you loop, all the components you pass through, you have to do a mental check. Do I know the resistance? Do I know the resistance? Do I know the resistance? Yes, this is R. Yes, this is R, which I'm trying to find. So there's only space for 1 unknown. There's this Chinese saying, one mountain cannot hide 2 unknown. Wait, what I'm talking about? One mountain cannot hide 2 tiger. So one equation if can. Please don't have two unknown. Not say cannot, just harder. Alright, so I'm gonna use the Kirchoff's second law here. This is 12. I will loop anti-clockwise because all the current is anti-clockwise. Like this. So for me, this one is 1 ampere, so 1 times R plus 1.5 times R plus current that comes out here, because everybody recombined or reunited already. All the current has reunited back to 4 ampere. So the internal resistance or the current that passes through the battery is 4 ampere. So you will take 4 multiply by 0.5. So what you have is 12 is equal to 2.5 R plus 2. 10 is 2.5 R. R will be equal to 4 ohm. Okay, is there a way to find the resistance of the resistor S?